areas of polygons used to find the surface area formulas for cylinders? Think about this question during the lesson. A contractor builds porch columns that are painted on all surfaces with a protective sealant. Each column is 14 feet tall and 2 feet in diameter. If the contractor has enough sealant to cover 150 square feet, can he seal all the surfaces of one column? Draw a cylinder to represent the column. A cylinder is a three-dimensional figure with two parallel circular bases that are the same size. The cylinder's height is 14 feet, and the diameter of each of its two circular bases is 2 feet. How does knowing the area of a two-dimensional figure help you find the surface area of the column? Draw a net of the cylinder. The net of the cylinder includes two circles for the two circular ends. What other shape is part of the net? Select your answer. The other part of the net is a rectangle. The other part of the net is a rectangle wrapped around the column. P, the perimeter of the circle, is equivalent to the length of the curved surface. The perimeter of a circle is the same as its circumference. Now we can use the net to find the area of each surface. Let's start with the two circles. They're identical. Find the area of the two circular bases, 2 times b. Use 3 14/100ths for pi. The area of a circle is pi times r squared, so the area of the two circular bases is 2 times pi times r squared. The area of the two circular bases is about 6 28/100 square feet. Find the area of the curved surface represented by the rectangle. Remember, the length of the rectangle is the perimeter of the circular base, 2 times pi times r. The height of the rectangle is the height of the cylinder, h. Find the total surface area. The surface area is the sum of the areas of the surfaces. The surface area is equal to the area of both circles plus the area of the rectangle. The total surface area is about 94 2/10 square feet. The contractor has enough sealant to cover 150 square feet, so he can seal all the surfaces of one column. And that's how you can use the areas of two-dimensional shapes to find the surface area of a three-dimensional cylinder.
What is the surface area of the cylinder represented by the net?
The area of one circular base, B, is pi times 2 5/10 squared, and that's because there are two of those circular bases, and so or it could be written as 6 25/100 pi. And then we have the perimeter of the circular base P is 2 times pi times 2 5/10, or 5 pi, because 2 5/10 would be 5 by adding the 2 together, so that'll equal 5. The height of the cylinder H is 60. And that is, I'm sorry, that's not 60. I'm sorry, the height is 9 5/10. I'm getting ahead of myself. And the total surface area of the cylinder is 2 times B plus P times H is equal to 60 pi square inches. And so 2 times B would be, B is the 6 25/100ths, and then the P would be the 5 pi. And then you substitute that and you get the 60 square inches.
What is the surface area of the cylinder represented by the net? Express your answer in terms of pi.
The formula, surface area is equal to 2 times B plus P times H is equal to 2. B is going to be pi r squared, so that all represents B. And then the P is pi r, and then the H is H. So 2 pi r, the radius here would be 5 because the whole thing, which is diameter, is 10, so half of that would be 5. So we substitute the r for 5, and then same thing in this part of the equation. And then the height in this case is 43 over 2, which is 43 over 2 is the 21.5 written as an improper fraction. And then 50 times r, because 5 squared is 25 times 2 is 50, so 50 pi plus 215 pi, and that is 5 times 43 over 2 times the 2, and that's 215 pi. Then you add the 50 and the 215, you get 265 pi, and pi just stays there instead of changing it to 3.14 or 22 over 7, so it's just 265 pi square yards.
A movie theater is designing new packaging for a cylindrical popcorn bucket. Which design requires the least amount of material for the container?
So shorter container, we have the bucket at the bottom, but it has no top, so it's just one circle. Then you have the rectangle for the cylindrical portion that wraps around. And then you have your formula, which is surface area is equal to base plus P times H. And then you have B again is pi r squared. P is 2 times pi times r, and then H. You substitute the r with the 2.5 here, and then you have the 2 pi 2.5, which is r again, and the height we have here is 8 inches, and then 2.5 squared is 6.25, pi plus 40, which is all of this multiplied together, and then you add the 2 together, you get 46 and 25/100ths pi, and then this time they have translated that pi to 3 and 1/1400ths, so you multiply that and get 145/100ths and 145 and 225/100ths inches squared as the shorter container's surface area. Then you have the taller container, which you follow the same steps, and this time you get 175 and 84/100ths inches squared. And then your conclusion is that the surface area of the taller container is about 145 and 225/100ths square inches. The surface of the shorter container is 135 and 84/100ths square inches. 225 thousandths. That was the other one. I apologize for the miswording. The taller container requires less material. So they would probably go with the taller container.
The movie theater is also designing new cups. The designer sketched nets for 2 cylindrical cups. Which design uses more material? How much more?
We're going to have to follow the same steps we followed in the example. Let me start by writing the formula. I have written my formulas, and now we have to apply the formula to the information we're given. So for the bigger container, we have 6 inches would be the diameter, but we need the radius, which is half of the diameter. So half of 6 is 3. And so we're going to substitute the R in the base. R is 3, so 3 squared. And for sake of my time, I'm just going to say what you put in your calculator. So R is 3 squared is 3 times 3. That is equal to 9. And then 9 times 3.14, we could do that now or we could do that later. So let's just do it later at the end. So we have 9 pi, and then we have 2 times pi RH. So R again is 3, and we're going to multiply that by 2. And then we have the height of the rectangle, which is 4. So multiply that by 4. So that gives me 24 pi. I'm sorry, that was not supposed to be an equal sign right here. So that's a plus equal sign there. And so now we have 9 plus 24, which is 33 pi. And so 33 pi, we multiply that together, 33 times 3.14, and you should get approximately 103.62 as the surface area of this one. So I'm just going to write that right here. Write that a little bit better. Just want y'all to know it's a struggle to write neatly on this screen. 103.62. Alright, now we have to follow the same steps for the smaller container. So I'm going to erase up to here because all of the steps are the same, just different numbers. So now we have the radius of the smaller one. We have 4 inches as the diameter. The radius would be half of 4, which is 2. So 2 squared is 2 times 2. So that's 4. So we have 4 pi plus 2 pi RH. So the R again is 2. 2 times 2 is 4. In this case, the height is 6. So 4 times 6 is 24. So we have 24 pi. So we add that up, and then we're going to get 28 pi. So 28 times 3.14 gives us 87, approximately 87 and 92 hundredths. So it says which design uses more material? It will be the bigger cup, and it says by how much more. How much more tells us we're going to subtract. So we subtract the 103.62 hundredths from the 87 and 92 hundredths, and we get 15 and 7/10 as the difference. And that is all.